So to interpret this dimension report, we will start by, well, of course we have all the heading information at the top. It gives you your part name. You could fill out drawing number, order number, variant, company, department, etc. The CMM type and number are automatically populated from the configuration of the computer, and we've logged in as the master operator here, but you could have different names on that. You can also enter your own text here if you want to add some more identifying text like run 1, or if you wanted to put in how many times you've run the part before, something like that. That might be helpful. And we have approval blocks. Part identifier is actually keeping count of how many times this program has been run. It gives you the date, tells you what you selected for your run values, and how many measured values you have, how many things are out of tolerance, and then how long it took to make that measurement run. Now this says 0 because I just dumped the characteristics into the dimension report. But this will actually record your cycle time if you run from the features list. Right. Now under your name, this is just the name of whatever you put in your program. And I didn't go back and modify these, although I think that's probably a good idea. It'll give you the measured value, which is what you actually measured on the part. The nominal value is what the blueprint calls for. And then you have your plus or minus tolerance. Your deviation is the distance in between your measured value and your nominal value. And then it'll give you a little preview, which is your low limit of your tolerance and your high limit of your tolerance. Your nominal is smack dab in the middle. And then this little green bar shows you how much of that tolerance you took up. Now, if we look at our Y value, number 1, that was really not all that descriptive. Y value is really not very descriptive to tell us what it is. But we see that our tolerance bar here has changed itself to red. It changed itself to red because we're out of tolerance. Now it's kind of hard to see which dimension is which when we look at it like this, so oftentimes you'll have balloon numbers on your blueprint. And balloon numbers are very similar to what you see here, but instead of having L1, this might say 1.875, and then there will be a number 1 next to it with a circle around it. So the number 1 with a circle around it is the balloon itself. That allows you to identify which dimension you're talking about really quickly. Let me pull up an example. So here's an example of a ballooned drawing, and it's pretty self-explanatory. You just go around systematically. In this case, it started at the 9 o'clock position and then went around the part in a counterclockwise direction. You basically just put a number next to each dimension, and that allows you to really quickly and easily see which dimension you're talking about and to make sure that all dimensions have been accounted for. So what we're looking at here, we want to make sure L1 through L6 are accounted for. Well, we might want to come back in and edit some of these names. Now, if we edit them at the dimension report level, well, first of all, it won't let you edit them because it's protected information. But secondly, it wouldn't update in Calypso. So we want to come back to Calypso, and we're in the Characteristics tab, and we can double-click on any dimension, and instead of calling this X value 1, that really is L1. We'll say OK. Instead of calling this Y value 1, that really is L2. And this one is L3, etc. Now the reason that this is coming in sequential, L1, L2, L3, is because I decided to write the program in the order that these dimensions show up. Oftentimes, you want your program to run path efficient, meaning you want it to move in the most direct path from one feature to another. In other words, you wouldn't want to measure something over here, then something over there, then something over here, then something over there, then something over here, then something over there. Really, you would want to measure everything over here first, then everything over here next, then everything over here, then everything over there. So we can reorganize our features list, or we can reorganize our characteristics list to go sequentially. So these ones are just going to be L4, 5, and 6 respectively. And I just want to show you that we can very easily move things. However, be careful, because if you're moving things in the Features tab, you are actually changing the order in which things are inspected. Right here we're going L1 through L6. Let's grab all of that and hit Run. This time, we are again not going to clear the existing results. We'll use current alignment, current selection, features list, clearance plane, slow through first feature, and 55. Slow the speed dial all the way down, and hit start. And notice again, we did not have to measure anything at all, and that is the beauty of this. That is the beauty of this Clear Existing Results dialog. Clear Existing Results allows you to either save the information you already have or wipe it clean so that you can do a fresh start and collect new data. And that's why that's kind of always the first thing you look at when you go into this run window. Right, so Clear Existing Results checked off allows you to really quickly apply any changes as long as you're not trying to get any more information off the part by taking probing points. All right, so now you can see that all of these have been renamed. We may want to add some more detail to this, but this matches up to the balloon numbers on the print directly, so that is good enough for what we're doing right now.